Hello, everyone, and welcome back to Flow Space 101 Science Flow. Today, we are continuing our unit on work and energy. In Lesson 1, we learned that energy is the ability to do work. We also learned about potential energy and kinetic energy. Today, we are going to discover something new. Energy does not come in just one form. It can be chemical, electrical, light, mechanical, thermal, or nuclear energy. And energy can also change from one form to another. Our essential question is, what forms can energy take, and how can energy change? Let's find out. Let's begin with a warm-up. Look around this slide. We have food, a lamp, a battery, the sun, a fan, and fire. What do all of these have in common? They are all connected to energy. Remember from Lesson 1, energy is the ability to do work. Food gives our bodies energy. A battery stores energy. A lamp uses energy to make light. The sun gives Earth enormous amounts of energy. A fan uses energy to move. And fire gives off heat and light. Energy really is everywhere. As we go through today's lesson, see how many different forms of energy you can find. Our first form of energy is chemical energy. Chemical energy is energy stored in substances. We can find chemical energy in food, fuels, and batteries. Look at the food on the slide. When we eat food, our bodies get chemical energy from it. Our bodies can then use that energy to walk, run, play, think, and grow. Fuel such as gasoline also contains chemical energy. Cars can use that stored energy to move. Batteries contain stored chemical energy too. So remember, chemical energy is stored in food, fuels, and batteries. And here is an easy connection. Food gives you energy to move. Next, let's learn about electrical energy. Electrical energy comes from the movement of charged particles. We often experience electrical energy as electricity. Electricity can travel through wires and carry energy to the things we use every day. Look at the fan. Electrical energy helps the fan blades move. Look at the lamp. Electrical energy helps the lamp produce light. Computers, televisions, refrigerators, and many other devices also use electrical energy. Think about your own home. How many things can you find that need electricity? Probably a lot. So our science idea is, electrical energy moves through wires and powers many devices. Now let's talk about light energy. Light energy travels from a source of light. The biggest source of light energy for Earth is the sun. The sun gives us light every day. Plants also use light energy from the sun to make their own food through photosynthesis. A lamp is another source of light. Unlike the sun, however, a lamp usually needs electrical energy first. And look at the solar panels. Solar panels can take light energy from the sun and change it into electrical energy. That gives us a clue about something we will learn soon. Energy can change forms. For now, remember, light energy comes from sources such as the sun and lamps. Our next form is mechanical energy. Mechanical energy is connected to an object's position and motion. It is the sum of potential energy and kinetic energy. Remember these from Lesson 1? Potential energy is stored energy. Kinetic energy is the energy of motion. Look at the roller coaster. When it is high on the track, it has lots of potential energy. When it starts moving down, it has kinetic energy. Together, potential energy and kinetic energy make up mechanical energy. We can also see mechanical energy in sports. A skateboarder ready to move has potential energy. A moving soccer ball has kinetic energy. So remember, mechanical energy is the sum of potential energy and kinetic energy. Now we have two more forms of energy to explore: thermal energy and nuclear energy. First, thermal energy. Thermal energy is related to the movement of tiny particles in matter. When particles move faster, an object becomes warmer. And a warmer object has more thermal energy. Fire, a stove, and a heater are all good examples. Now let's look at nuclear energy. Nuclear energy comes from changes in the nuclei of atoms. Atoms are incredibly tiny, but changes inside them can release huge amounts of energy. The sun produces enormous amounts of energy through nuclear reactions. Nuclear power plants also use nuclear energy to help produce electricity. So remember, thermal energy is related to heat and particle motion. And nuclear energy comes from changes in atoms. We have learned about many forms of energy. But energy does not always stay in the same form. Energy can transform. Transform means change form. Energy transforms when it changes from one form to another. Look at the lamp. It starts with electrical energy. Then the lamp changes that electrical energy into light energy. So, electrical energy, light energy. Now look at the blender. It uses electrical energy and changes it into mechanical energy, which makes the blades move. And the stove changes electrical energy into thermal energy. So when you hear the word transform, remember, transform means change form. Energy can change from one form into another. Energy transformations happen all around us, especially at home. Let's look at some examples. First, solar panels. They transform light energy, electrical energy. Next, a blender. Electrical energy, mechanical energy. The electricity makes the blades move. A stove changes electrical energy, thermal energy. A charging battery changes electrical energy, chemical energy. The energy becomes stored inside the battery. And a lamp changes electrical energy, light energy. When you look for an energy transformation, ask yourself two questions. Where does the energy start? And what does it become? Think. From 2, you can probably find many more energy transformations in your own home. Now we need to understand two words that sound similar. Transform and transfer. But they mean different things. First, transform means change form. For example, a lamp changes electrical energy into light energy. The form of energy changes. A blender changes electrical energy into mechanical energy. Again, the form changes. Now let's look at transfer. Transfer means energy moves from one object to another. Look at the billiard balls. One moving ball hits another ball. Some of its kinetic energy transfers to the second ball. The energy moves from one object to another. The same thing happens when your foot kicks a soccer ball. Energy transfers from your moving foot to the ball. So here is the easiest way to remember. Transform, change form. Transfer, change place, from one object to another. Energy can do both. Let's review some of the important forms of energy we learned today. Mechanical energy is energy connected to position and motion. It includes potential energy and kinetic energy. Kinetic energy is the energy of motion. If something is moving, it has kinetic energy. Thermal energy is related to heat and the movement of tiny particles. And nuclear energy comes from changes in the nuclei of atoms. But remember, we learned even more forms today. Chemical energy can be stored in food, fuel, and batteries. Electrical energy can travel through wires and power devices. And light energy can come from sources such as the sun and lamps. Energy is all around us in many different forms. And these forms can work together to make our world move and change. Great job today, scientists. You learned so much about energy. Today, we discovered that energy comes in many different forms. We learned about chemical energy, electrical energy, light energy, mechanical energy, thermal energy, and nuclear energy. We also learned that energy can transform by changing from one form to another. And energy can transfer by moving from one object to another. The next time you turn on a lamp, eat some food, kick a ball, feel heat, or see sunlight, think about the energy involved. Energy really is everywhere. Keep being curious, keep exploring, and keep learning. Thank you for learning with Flow Space 101 Science Flow. See you next time. Bye, everyone.